In order to achieve this particular task, we're going to actually start using our serial monitor on the Arduino. So this will allow us to feed data from the Arduino microcontroller via the USB cord into the computer and just take a look at what's happening with that data on the screen. So let's get started, shall we? So here we are with our first Arduino sketch. So I'll just take you through what we're doing here. So initially we are declaring a integer type of variable called potPin, and we're giving that the value of A0. So this just tells our microcontroller that the pin for reading analog signal on potPin is A0. In our setup here, you can see we've got the serial.begin command. So this is going to tell the Arduino to start communicating via the serial monitor. So that's going to be transmitting data through the USB cable to the computer, and the number 9600 here, this represents the baud rate or the bit rate of the data transmission. So it's very important that we match the baud rate with the sending and receiving devices, and also that we use a baud rate which the Arduino is happy to communicate on. So we're going to use 9600 as it's a very standard setting. So down here in the loop, we are setting the integer value. So this is declaring a new variable which is called value, and we're setting it to 0. In the next line, we are actually now changing the value of that variable to be equal to the value that is read using the command Analogue read on potPin, which, as we've declared up here, is pin A0. And finally, we are doing a serial.print. The LN here stands for new line. So serial.print is going to print the number on a new line, and then we are printing the variable value. So if I upload that to our Arduino now, and if we open the serial monitor, which I mentioned in a previous video, you'll see the communication starting to take place. And as you can see, the numerical value 0 here is being printed on the screen on a new line each time, and these lines are just scrolling forever. I'm now going to rotate the potentiometer, and we can see that those values are now changing. Those values, of course, are changing from anywhere between 0 and 1023. So this means that our analog signal, which can be varied infinitely between 0 and 5 volts using the potentiometer, can be mapped into an integer value of 1024 possible different numbers.